Hello and welcome. I'm Bill Wake. We're here working on an Elm interpreter written in Swift, and we've got expressions that are very primitive so far, just integer and literal. And today we're working on comments. We did last time the dash dash to the end of the line comments, and today we're going to tackle the nested comments. Let's get over to the environment. Okay, so they start with a brace and a dash, and they end with a dash and a brace. I ran across a language that was obscure to me called Gopher that used the same comment structure. So I don't know if that's something from Haskell too, or where they picked that up, but um, you're allowed to nest other brace dashes inside them. But we're at the beginning, so we're a ways from that. All right, so at the end of the day yesterday, we created this test that I believe should be failing. We forgot to warm things up here, but uh, we want to look at some cases. Here's an empty one, brace dash dash brace, and here's one with non-empty because it's got a space in the middle. This one's got some internal dashes. This one ends with dashes, and this one has nesting. We need more test cases than that for nesting, probably. All right, and I guess we're testing. So we're going to try and input empty XX, and it should consume the comment return ignored and then leave XX for the spaces. Excuse me, one sec. Okay, and since we don't do anything with comments right now, I think it'll blow up right on the braces. Now the nesting, that's an interesting place to be, and the reason I say that is because our definition so far. Let's go over here while we're waiting. Okay, we define spaces. It's a series of parser combinators and functions, and end of line comment. We had a sequence of dashes and stuff up to end of line. But nestable comment, we just put some junk in there for now. But it's going to have to be recursive. So defining a name that equals itself might be a little problematic. So I'm anticipating some challenges there. I think we can just write it as a separate parse function, separate function that generates a parser, I guess. But we'll see. We'll wait, I guess. There we go. Okay, yeah, I think it's crashing somewhere. Yeah, found a nil here. Right. So in our check parser, let's go back. Here's our test. We call check parser. It's built around the assumption that you're going to succeed and return AST. Yeah, we can improve that name, but it's supposed to return AST, the thing we're parsing to, and uh, the rest of the string. Okay, and because we assume it's going to return it and have an exclamation point saying if it's nil, which means syntax error. Basically it says we got a syntax error. Now maybe it might be worth. Yeah, I think let's improve this little method because it's the thing used everywhere. We'll comment this out, kind of deactivate it anyway. Parser test helper. Okay, so one thing I know is this name should be better. It should say succeeds because it really does only apply when you intend to succeed. So check parser succeeds. Okay, and then I think what we can do is let's pull a result. What are we calling it? Um, call it. Okay, just to get through this. Okay. we're going to assert not nil. If we can wake up. Assert. Oh, I guess I'm. Okay, not nil. Foo. And then we can let AST rest equal foo bang. Okay. Can I put a message on here? Should successfully parse. Okay. Non-optional type. I guess. Is that okay? Okay. Let's run this again. I'm thinking this name should be expected, because that's the point. I don't know if I can rename this. Oh yes, nice. Okay, good. Expected. All right. Expected AST, expected rest. Okay. Oh, I guess I should reactivate my test. So I'm hoping I get a better message before it crashes. Oh, whoops. We want that off. And then it probably needs to be here. Well, okay. Let's be more. Yeah, I just don't like this thing of crashing when I'm trying to add a new thing. Let's see if let's see if I can remember the syntax here. If let ast equal rest equals foo, then do this stuff. If I stop, I'll get a little more help. Okay, so it can fail early. Let's rename this. I guess it's actual. And this AST this is really the result. All right, so how's it looking? You give the parser input expected and rest, and it gets the actual result, checks that it's not nil. Otherwise, it peels them apart and then makes our assertions. Okay, I think that's gonna work the way we want. Oops, I could have sworn I ran tests. Oh, I did. Yeah, they run them anyway. Okay, now I'm getting a test with one failure. And how's it looking over here? Should successfully parse. Yeah, that's better. Okay. And, I don't know, maybe I'm flitting around too much, but I'm going to comment this back out again, or deactivate it. We have this parser succeeds, and we have a number of tests for parser fails. I think we need to get the parallel helper done. It's just not everything's going to fit that pattern, but enough of them do. Okay, so we did this yesterday too for the other one. Whoops, I don't care about that. Character is digit does not need this, but some of these will. So let's get up to the top. Let's look for nil. Yeah, there's some assert nils. So you get a parser and you get an input and it should reject. So we'll extract it from this. Can I extract a variable? No, because who knows? Okay. So parser is match, input is x1, and it should assert nil. I'm gonna make a method, and I know it's kind of minimal here. Yeah, I'm gonna do this. Let's extract this method. Oh, come on, you can do that. All right, well, it's function check parser fails rejects. It's going to take a parser of A. I guess we can do this, and it's going to take some input of string, and it's going to call xct assert nil. Parse my input. Yeah. Okay. So I should be able to say check parser rejects. Parser is parser. Input is input. That goes away, and this test should still pass. Okay, and let's move this method over here. I guess rejects can come after. Okay, anything else we need to do here? Okay. I don't know if, I don't think this will be confusing. I almost think you could inline all this. How's that read? I think we're okay with it. Okay, so test match rejects end of input. I'm just going to borrow these. Okay, so match character is digit, yes. And the empty input. Okay. Parser succeeds. Let's how about rejects? Parser is match xy. Input is x. Matches, this one fails. This one's a little more complicated. I'll leave it out of line. x23, there's the parser. Parser input is just x. I think I kept it. Assert nil. Parser will keep. Okay, that's that one. Pull this in directly. The input is A. And, you know, I look at this as a stage on the way to more generalized stuff. We kind of moved from straight out code to a helper method that's more or less a parameterized test, and we could loop this into a big parameterized test if we were inclined. Elm parser literal. Okay, so in that sense, I feel like it's a natural progression of the thing, but we'll see where it goes. I don't feel the need too much to push everything towards the big automated kind of thing, but you know, there is kind of a difference in the TDD. You want one unit test driving you forward, and then at some point you get these tests, and especially with compilers and things like that, it's all these string inputs, and the string input produces some output. You know, there's it's kind of like a builder pattern or a facade in a way. You know, there's in some sense what we're doing is converting strings to strings, and you know, from the test perspective, it looks very simple. You know, you input this string, did you get back that string? And yet there's a whole lot of functionality going on behind that for that transformation to occur. So it's kind of a weird place to be, and you end up writing these little tiny tests, but they're all doing similar stuff. So I don't know. It's I guess we got to hit the right balance. Okay, so we did integer. Let's do float. We just check float succeeds. Okay. I don't know why we didn't test more, but succeeds. We did spaces. Did we do spaces? No, we don't have any failing. I guess comments are kind of optional. All right, so let's commit this. Test helper. Okay, so a little distraction from where we're going, but I think it makes our steps easier. So I'm willing to pay that little penalty. It's only 9:20, so it didn't take too long. The last one took like 20 minutes by itself. Okay, integer test, no. Expression test, no. Parser tests, probably not. Elm parser. Comments, that's the one. Okay, now let's get serious on this one. Okay, so it should successfully parse. It did not, and we don't have any we don't require anything yet. So okay, we have this match that takes a string, so let's take advantage of it. We want to match dash bracket space bracket dash. Okay, who chooses these things? Okay, and followed by, I guess, so we have a sequence. We're going to have a match dash, and then we're going to have a match other end. Close the match and close the sequence. Whoops. I don't know how to make this look compelling. Maybe this. Okay. So match these two, then match these two, and combine it into a space and call it a day. Or combine it into Elm ignored. I don't think, is this used anymore? Find in workspace. No, it's not. It's sort of a failed path. Okay, so we should pass. Cool. Okay. Nestable comment matches empty comment. Yes. Let's tackle the next one. Matches non-empty comment, I guess. Okay. And it's got some similarity. Okay, so this case, we want, well, we can put anything we want in there, but I'm going to put, well, I'm going to put some spaces too. Okay, because we're matching up to the dash thing. So, this should fail. Okay, should successfully parse, but it does not. Now, this is where it's going to get a little bit funny. Okay, so doing one thing at a time, I guess, one step at a time. If we got up to a dash, of all the guesses, I don't think that's the one I would choose. All right. We get up to a dash, so we're saying match the break with the opening brackets. Skip to, I think I ended up calling it. And skip forward till you get to the dash, and then match the dash. All right. And the skip to matches a bunch of characters and does that. Now, I hope we're on this edge of a parsing. Well, we have a parsing challenge. The way we're doing this thing, we're returning arrays of things, and sometimes you have single things, and sometimes you end up with arrays of things, and it's become a mess. And what I've learned is that's sort of parser combinator version 1. There's a better way. So we're going to get to the better way, but let's get what we can for comments first. Okay, so our test passed. Good. All right, now it's going to get trickier. So we've done empty. We've done non-empty. I don't know which one's easier. Maybe this one. So let's try test nestable comments ending with many dashes. Okay, and so our input, let's make like that. We expect this will fail. because we're only going up to a dash, and then it's getting there and it's expecting dash brace, but it's got dash dash instead. Okay. So I don't know if you ever build your grammars up one at a time like this, but we're gonna match dash dot ManyOne, and I'll take it out of here. So this is closing dashes and that, and oh, ManyOne. You gotta type the one. Okay. Do you accept it? Yeah. Here we go. This is what we went through before. What did I do? Oh, I think that putting these in the bracket maybe worked. No, that's not the issue, is it? Okay. Yeah, this is where you get this when you got a foundational issue. That's how it shows up. So what we have is we have a ManyOne parser always returns an array of the stuff it's given, because when you have one or more, you're going to get a list of things back. Okay. But did we put a unique or something like that in yesterday? Parser. Skip to. Sorry. Unwrap. Yeah, let's try that. Okay. Has no member unwrap. Interesting. Okay. What's wrong with that? He's a parser. He takes a parser returning an array of stuff. Oh, it goes on the outside. And I don't know, did we abandon this approach yesterday? The existence of this is a consequence of what I'm talking about with this different approach to parser combinators. Okay, but let's see how we're doing. I believe this should pass. Okay, so what? All right, so the next test, the internal dashes. So I'm trying to remember my. When you have a comment like this, you can write a regular expression for it. If you get nesting, you can't. So we do have an issue for that. But if I think what we want to do is attempt to match this. And if we don't, then the reason is we had a dash in front. And so I think we can basically reject the dash's brace and come back and just try dash by itself, and that should be okay. And then we need to do a repetition one of this too. This is multiple. Okay, so I guess we'll take this test case. Well, and again, you see I'm getting these very similar test cases, and it's like, do I want another level of abstraction on them? Nest ending with internal with one set of internal dashes. one set. Okay. All right, and this should fail. One failure. Not should successfully parse. Maybe I should say but didn't. I don't know. Let's. But did not. Okay. Okay, so this failed, and that means our Elm parser is not sophisticated enough. Okay, so we skip to unwrap, match that. I don't know. This is kind of complicated, isn't it? So we got to match if we. I mean, somewhere I got to have another ManyOne, right? Okay, I don't know. Let me try and write a regular expression for this thing. So we're going to have a dash, and then we're going to have not dash star, and this is informal. Okay, so that's what we have up to the skip to, and then we have something at the end. We got this. Okay, but we need to, if we see a dash, well, it's sort of an optional dash, not dash. Or is it a repetition? Does that even help? Okay. How's this? So you get your bracket, you get a bunch of non-dash characters. If you see a dash followed by a not dash, that's fine. I guess the star is, well, let's make this the optional. Okay. If you see a dash followed by a not dash, that's fine. And do we need our many dashes, or can this thing handle it? Do I need this? Okay. I don't want to make a horrible expression. Okay. But all right, so I get my dashes. I get my bracket. I get my non-dashes. I get a dash followed by a non-dash. I can do that. I guess non-dash plus star. Or do I even need that? What if this is star? That might do it. Okay. Non-dashes, I hit a dash followed by as many non-dashes as I want. That's fine. And then after a while, I get a dash. And I guess I got to decide, am I going down the middle path, dash, non-dash stuff? Or am I going to the end? I think that's okay. Okay, so what we got? We got our match. We got a skip. That's our not dash. Okay, we should find a dash Well, we're finding a sequence. Such an odd guess. Okay. The sequence is a dash followed by a skip to dash dot ManyOne I think, do I want to unwrap this thing? Can match, this can be done only. These things. Okay. Okay, so I've got dash, the middle one, dash, not dash, repeats, and then I need to repeat my sequence. I don't know if I can say sequence.ManyOne. Oh, shoot. I don't have a many. Oh, I don't think. Do I? Seems like I tried that before and got the wrong one. Yeah. Okay. So let's stack this up. I'm going to say ManyOne for now. And then we're going to go back and do a many. Okay. And I feel like, my goodness, am I going to unwrap the unwrap? Unwrap that ManyOne. Whew, I think this will fail because we don't have, well, we might. No, we got dash dash, so no, it's not going to work. Yeah. Okay. We ran out of file, as it were. Another thing we have to address. Okay. We got a failing test, but it compiles. So I'm going to deactivate this test. And we're going to implement a many parser. So we've gone through this before. We're kind of we've accumulated a lot of parsers by now. So we don't have to do this all that often at this point. But at first it was like every new little feature meant a new kind of parser. Well, up till now, we've always done one or more. We haven't done any many or mores, except for that skip to. And skip to just looks for, do you have any of this character? So we'll take a 2-minute break, come back and tackle that many parser. It's a good parser. 0 or more is a very common grammar rule. All right. I'll see you in 2 or 3 minutes. All right, welcome back. This should no longer be an issue. Okay. Oh, well, we've messed up our other tests. I think we will. Let's see. Which test is this? Check parse spaces. Okay. I don't know. I may have messed them all up. Yeah. We'll block them out for a moment. Okay. What I want to do is parser and tests. Okay. So parser, we have a ManyOne matcher, which is one or more. ManyOne, okay. I believe it could be improved, but that's what it is. And we want to make a many parser, M-A-N-Y. It will be small, but let's write a test for it. Okay, so here's ManyOne. ManyOne succeeds if it's parsed once. Okay, so many function test many succeeds if parser succeeds multiple times. So we'll check parser succeeds. It's easier to copy than to deal with all those. Okay, so match character digit many. Many 987X should be fine, should find the 987, and the rest should be there. Okay, and we'll get our many parser. Is a parser of, I think it's a parser of array of A. Okay, because it like the ManyOne, it can return multiple values. Oh, no wonder I'm not formatting. Okay. And all right. So I think with this extensions must not contain stored properties. Computed property must have access or specified. Yeah. Well, let's return I guess we'll return self.parse. So you say many digit. I'm just going to let you match one digit. No. Can I return only? Only. Okay. We're just trying to get it to where we can make our test fail. So this test in 160 should fail. Right? Okay, so it only peeled off one value. All right, but I think the initial implementation is even easier. We can return ManyOne. Okay, so our test wants one or more. Well, let's just return ManyOne, and should pass. Okay, and now we make a test for the 0 case. But it succeeds even if parser does not. Okay. So we want to match just the input X, and we expect to get an empty array back because there's no matches, and the input doesn't get consumed. Okay, so maybe this is more convincing. Okay. All right. So this I expect to fail because ManyOne really does want to find at least one. If it doesn't fail, then we've got something wrong. Okay, that would be That would be interesting. All right. But I think this is just ManyOne dot is where's our optional? Optional takes a parser, so optional of ManyOne. And if it's the only thing in here, I don't really need the word return. Okay, so run and should pass. And this is where getting these things built up, I mean, I shouldn't talk before it passes, but getting these things built up, now I can define them in terms of each other. And that's a lot simpler than when we got ManyOne working, for sure. Okay, so it's nice when things just kind of click together. That's good. Now let's go back. Let's check this in. So we defined a many combinator. Parser combinator. And I don't know, whatever confluence of things in life, but it's driving me to. I never real. I did play around with Lisp and some variants quite a bit years ago, and just kind of when static functional programming was kind of becoming a thing, I kind of got out of the Lisp stuff and ended up in the Java, C Sharp, Swift, whatever traditional kind of world. And now I'm finding I got to learn this stuff. And then the other thing is the combinator stuff. You know, I kind of looked at it enough to go, oh, that's kind of a cool thing. It's very mathematical, and you should look at it someday. And I think someday is coming for me, like real soon. So it's starting to make sense, but I still got these holes. So you get to ride along. Okay, let's see. And I should say, if you're not finding anything confusing, definitely speak up, or just to say hi. That's great in the chat. I am trying to monitor it, keeping it live over here. So let's see. So let's uncomment our tests again. And this is where these guardrails are really nice, because this regular expression stuff is super easy to mess up. Now we still have this issue about the returning a single array versus a double array versus a triple array versus whatever. And with comments, it doesn't matter because we just don't care what's in them. All right. Let's see. So I don't know where we're even blowing up here. Have we comment? Nestable comment matches empty comment. Okay, so our Elm parser does not match an empty comment. So it should allow nothing here. Okay, these many. Yeah, so our ManyOnes become manys. On the skip to, this is optional. How's this optional? If you have a dash, I guess if you have a dash, 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 you repeat those, and then you go to dash close, then you're okay, I think. Okay. And then the many here corresponds to this star. And I don't think we need this one. We don't need a many here. We just need a, well, I think I can go back to this. Okay. Yeah, this unwrap stuff. And only. Okay, so we're going to match our opening bracket, skip non-spaces. From then on, we get a dash and skip any more non-spaces until the end, where we should see a dash and a brace. Okay. The other issue I worry about with this, let's see if it goes. If our optionals, okay. What's the issue I'm worried about? If our optional doesn't get taken, does that cause an issue? What test are we on? Check parser succeeds. Nope. Spaces, comments. Nestable comment matches the empty comment. Okay. And this debugging, this is another thing I've learned on these grammar parser combinators. The debugging is much, much tougher. All right. Unexpectedly found nil while unwrapping an optional. Meaning our parser did not succeed. Well, what is this? Yeah, so we can kind of see things coming in. Here's the skip to, but we can't tell which skip to this is, I don't think. Maybe we can. Will it? No. I mean, it's passed to it almost as a data structure. I guess what we got? We got combine of sequence of unwrap of optional. Let's just take a look at our grammar. This input, if it's empty comment, it's just open brace, close brace. So our grammar appears to require something. Okay, we got this. Skip to dash should be okay. Let's hide some things. Okay, let's see if we pass anything with this. Two failures. Okay, who are the two? Oh, with many dashes and internal dashes. Okay, so we got the first part right, but apparently our grammar is requiring let me do it this way. Okay. So now we are requiring this match. But the whole thing is optional. Oh, boy. Okay, so he matches the dash. Well, I would have thought this sequence would fail. If presented with dash, ooh. Oh, it can't be one of the braces either. That's kind of a problem. Okay, because this will match. Yeah, that's kind of what's going on. I think this will match the dash, and skip to will be perfectly happy to match a brace. And oh, this should be not brace, right? Not a brace. Okay, we don't want to skip to. If I do skip to brace, it's just going to match one dash and skip forward to the braces, and then still be looking for the braces. I want something that does a not match of one character. Okay, because if it's a brace, then our comment ends. We should take the other path. if it's a dash, okay, oh, this expression is so easy to get wrong. I taught compilers way back when, and you take this as one of those hard exercises, and almost nobody gets it right, including I've messed it up plenty of times as you're watching in real time. I don't know. Do I need a not a? I think I need a not any of these characters. I think I need this. Okay, so I want a character that matches anything except these characters. Okay, I think again we're going to have to go implement something. Let's see who fails on this. No, it's not even right. It's not even wrong. We know we got 2 failing tests with this. I think we need another combinator, or at least another parser, and it's the accept parser. 2 tests, and it should be the last 2. Yeah. Okay, so I'm stacking up again. All right. So let's go to our to-do. This is the 20th. Palindrome day, if you write it correctly. Story is ignore nestable comments. Okay, and we'll take that up here. Well, it's a better phrasing. We added a mini combinator. And I think right now we're going to add an accept combinator. A little confusing because it's not an accept, it's an accept. Let's see. So save that. We got our parser. This is kind of like match. All right. So we want to make. Nope, that's not it. Where's parser tests? You know, there used to be a button I could hit, I think. Maybe I'm misremembering my environments. Okay, so let's go up where match is. Match, 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 match. Okay. Let's test accept for acceptable letters. Okay, and if we're going to match XY, the input XY, I'm going to say accept XY, and the input is Z, ZXX. My expected result is a Z, and the rest should be XX. Okay, so I'm going to parse everything except any character except XY. Okay, and does not build, so we need an accept. Okay, and it's going to look a lot like match. Function accept. This is unmatches, non-matches of type string. It's a parser returning character. Okay, because, yeah, like match is a returning character. Okay. And we're going to return, let's just return match of at. Okay, just something to get a failing test. Oops. Cannot return expression of parser of bracket character. Okay, we got two match parsers. Oh golly. $0. All right, failing test. Good. Okay, so I think all we want to do is we want to call match, and we want to say character is, let's say, non-matches dot contains. I think there's a contains. And I think we put spaces around these. Apparently that's not it. Oh, how about a not? Yeah, okay. And I guess I would be okay with, oh, yeah, that's fine. All right, and now let's test it for a rejection. Function test except rejects unacceptable letters. And this is a parser rejects. The parser is accept XY. And at the input, and I'll just make sure we're not grabbing just the first character. This should pass. I think we've done it in a way that makes everything, yeah, okay. So again, the combinator just kind of slaps right in there easily. Using it is the trick. All right, so we added an accept parser combinator. Okay, and our to-do, we can move that down. Added a many, added an accept. All right, and we're still trying to get these comments going. Okay, so let's take that out. And untab that. All right. So now my claim, probably less believable because you've watched me fail with this already 3 times. This is accept. An unwrap. Accept many. We can do that. Parser of character to parser of type of character. I've got another. Let's see. Accept returns character, right? Accept returns a parser of characters. Many returns array of. sequence, where's many? Many returns a parser returning an array of stuff. A parser of character to expected type. Maybe I don't need the unwrap. I guess sequence is fine with the minis. Yeah, okay. Oh, man. Okay, cannot convert. Parser of character to expected type parser of character. Match. My match is confusing me. I don't know if it's confusing you. I've got one that's returning characters and one that's returning arrays of characters. This returns an array of characters. Okay. So he doesn't need the only. Cannot convert value of parser of character to expected type. Which one is it complaining about? Let's take one and unwrap off. I mean, in principle, once all the types are right, it should be okay. But, all right. Except, okay, so we got our match dash. Have we got everybody reactivated? Let's do that. All four. Okay, so. No. Okay. So it may be something's wrong with our optional calculation, or there should be some alternatives. Okay, so everything fails. Okay, so we require two characters. Skip 2. Let's make sure skip 2 is happy with none. I guess we know it is, right? Because we result is none. If it equals end value, yeah, we could go through the loop 0 times. If the end value, if the value we're skipping to is dash and rest.first equals dash, then we come in and result's still empty. Okay, so this matches 2, this matches 0 or more. The sequence matches 0 or more, followed by this. Okay, so I feel like it's like our sequence is not handling the case. I don't know what comes out of this unwrap sequence. So our sequence is we match a dash, and that's a many. So you would think that could be 0 times, because we don't want it to consume anything. The only thing I wonder, again, I've got these two sequences. This one wants an array, and this one just takes a list. The list one, and they're very similar. It's you can see this is an array of parsers of A, and this is a parser of array of A. And this one produces a list. Maybe I'm using the wrong one. let's try it. Sequence that. If this works, then there's something wrong with my two sequences. They should have the same effect. Okay, 4 failures. Oh. Do I need the unwraps now? I think maybe I don't. Oh, golly. Okay, well, it's time for a break. Let's take the break. Maybe 2 minutes will clear my head or inspire you to write a scathing explanation of what I'm stupidly missing, because I don't see it. All right, see you in a couple. All right, welcome back. Okay. Ugh. All right, let's try this. Put this back. Okay, at least the types are right. Okay, run this. See, we should get the failures again. I may have to stack this up and just... Yeah, I'm just going to deal with the parser. I wanted to avoid that for now, because I'm not sure I fully understand. No, I'm sure I don't fully understand it at this point. The new approach. So it's going to be a little weird. Okay, so this should pass, but we're not testing any of our comment stuff anymore. Okay, so let me just put a comment in here. Put on hold. All right. I don't think we'll forget it, but you know, okay. All right. So let me... So I'm working off a couple articles. Let's see, what's the name of this one? The author. Do I have a window? No. Okay, so one of them is this article, Parser Combinators in Swift. And the other is by Hutton and Meyer. Let's see if I can just get it like this. This one was super helpful. Maybe because it made me feel better, but the basic idea, and they do a little different approach than we're doing, but they've defined a parser is converts a string to something in a string and all that in an array. Their arrays are always 0 or 1, so we've just used the question mark and they've used an array of stuff. Okay, but let's see. So basically, parser combinators are parsers that build things out of other parsers. So when we have the sequence parser, it takes 2 sequences input, like our match dash and our match accept, and it produces a parser that produces the pair of them on the output. And let's see. This is the key thing to me. At first sight, the sequence combinator might seem natural. Okay, it is. That's kind of what we're doing. Okay. However, using seq leads to parsers with nested tuples as results, which are messy to manipulate. So in their case, they've produced an ordered pair, And if you did more of them, you'd have, a pair of a pair of a pair of pairs linked, with a pair of a pair of a pairs, and it's messy. Okay. And that's what we're hitting now. It's all the time of, do I have an array of these things, or is it an array of an array? And it's creating the mess. Okay. And the answer is use a monad. So, we're going deep. But basically this, I don't know, the monadic sequence combinator, I didn't expect to deal with this on the way into the project here, but okay. It takes a parser and it takes a function. If you give me an A, I will give you a parser that produces B, and the whole thing returns a parser producing B. So it's not, well, intuitive means I don't get it, right? So yes, it's not intuitive to me why that's going to help us so much, but we're going to be using it somehow. We're kind of using it to peel things off. Now the result, let's find sequence down here. Okay, so the result is we define a sequence operator. Where did they do it? Well, there's bind. Yeah, here we are. Define the sequence operator. P sequence with Q means P binds with some function. What's the function? It's lambda x goes to Q bind, blah, blah, blah. All the rest. Okay, all this is the function going in. Well, it doesn't highlight, but thank you, PDF. But the lambda x to the end, I believe, is the function going in. It may not matter. Assuming sequence is associative, right? We can do them in either order. But at any rate, there's the parser. There's the rest of it. The x goes to result xy is the function. And we are going to, we're going to apply the function to the list of stuff. Okay. Result xy, he's defined result to just return the thing at the front. I'll go back to it. Result, you give it a value that you wish was a parser, and it gives you a function that when you give the input, it slaps the value on the front. So it's just sort of a way to inject the value into the stream. Okay. And so let's see, where's that sequence again? What's not clear in my head right now, I mean, I can mechanically say, yes, I see that you plug in lambda x goes to Q bind y goes to result xy as the function, but I don't have the intuition of why does that quite work. So I'm flying a little bit on blind trust here, but what I'm going to do is we're going to take a real sidetrack, okay, and define a bind operator and a sequence operator. And if that works well, we should have a sequence operator that produces, I think it's going to produce a result. I think it's going to produce a parser of the list of stuff. Okay, because I'm seeing concat here. Okay, so this bind is given the parser. Okay, so parser P binds with the function F. Okay, then we're going to call P's input. We kind of got to read right to left. Get P's input. Call that the pair V, that's the token we're getting, and input prime. Okay, so just like ours, we're returning a ordered pair all the time. Basically, that's what they're doing here. Return this ordered pair and apply F to the V part. Okay, so V is of type A because it's a parser returning A's. So it returns an A and an input. And the function V, function applied to V, produces a B. And so we get the B with the resulting rest of input. And then concat, I think, and this may be where us returning singleton optionals is not helping, but this is really a list. No, that I'm not clear on that. Yeah, their result is a list. No, it's an ordered pair. It's a list of ordered pairs. That's what I'm trying to spit out. Okay, so here's a parser, takes in a string, produces a list of ordered pairs. And I'm not familiar enough with, this is the Gopher language, by the way. So I'm not familiar enough with this, but I think this bracketed thing is basically saying apply this to everything in the list resulting from P input. And then flat map, concat is basically a flat map. He says that somewhere down there. Flatten to a single list using concat. Okay, results in a list of value string. Okay. And so this function is smashing the arrays down so we never have to deal with arrays of arrays of arrays. Okay. And that was the flaw in the original parser. Okay. I mean, it is a parser combinator because it takes two parsers, but it returns these things that produce nested pairs if you put two sequences in a row. And since we want to put lots of stuff in a row, we got lots of nested things, right? Because we're talking about our opening brackets followed by a bunch of characters, followed by optional dashes and other characters, followed by dash star or dash brace. You know, that's 4 or 5 or 6 things. They're all smashed into a sequence. And so we're getting this thing of parser of characters, or, double arrays. Okay. And so my plan of attack is we're going to define a bind operator that works in our domain. I may have to make our parse results return arrays because that may be part of the secret here, that it's just always it's always got a one level array. So my thing that returns one character, I'm not sure that's helpful or not, but they have one like that. Well, okay, so he has a function sat, which is like our match. It takes a function of characters to booleans and returns a parser of characters. But remember, in his framework, parser of character is returning an array of characters, array of character plus rest of input. Okay. And that uses bind as well. Okay. Now his formatting throws me off. I mean, the arrow's like this, but I'm pretty sure it's supposed to be lambda x goes to all this stuff is the function coming in, because that's going to either return a wrapped up result or it's going to return 0, which is his fail. Okay, so I mean, I've definitely spent at least a few hours trying to work my way through these things and understand. And, so I give you the 10-minute lecture on it that doesn't make sense, I guess. But the bottom line is we're going to go into parser and we're going to define some, I don't know what you call this. It's not a story. It's kind of a big refactoring. And make our parser combinators use bind. Okay. Now, not every parser will be affected directly. Where's the one I'm thinking of? The alternative one. Yeah. All right. So function of A, of the bar, meaning A or B or C, already results in, it gets a parser of any type, same type for both, and produces a parser of any type. Because you're picking one or the other, you don't need to wrap things in another layer of brackets like the many parser has to, or the and parser. This, I don't think we're using. It was my earlier attempt to make a parser operator, but again, we're in this mode of parse of one thing produces a parse of array of things. So all your arguments have to be modified to produce, to have the same number of parens, and then your result has one more, or brackets, your result has one more. So that's why we're using unwrap and only, only to wrap things with extra parentheses, and unwrap to peel them off so we can get them all lined up the same. And that's the stuff we're going to try and get rid of. So in effect, I think I'm going to just start a new test. And it's a bind. Well, what are we going to say bind does? Well, one thing I can do is fail. Okay. If the inner parser fails, if the parser fails, the whole bind fails. Okay, bind fails when parser fails. Okay, that's a true thing. All right, and so we want to, I guess we want to check parser fails, right? Parser rejects. Okay, our parser is going to be bind. Ooh, I have a bind. I don't know why it liked that word so much. It should not be suggesting bind to me. Okay, but maybe we'll have to make our own bind. Okay, bind takes a parser and a function. Okay, so let's just make it match match digit. How do we do that? Digit dot is digit character dot is digit. Okay. Cannot convert value of 32 to parser of A. Yeah, well, we're working on a different parser, a different bind. Okay. I guess our input string is going to be something that's not a digit. Okay. Bind match character is digit. That's the parser. And then we need a function. Okay. And I think we're just going to, we'll do an identity function. We'll just return the thing we're given. Okay. Okay, yeah, this is some other meaning of bind. Is there another word I can use for this? I want to say monadBind. It's like, I feel bad using the word monad when I don't really truly understand it. So, I mean, it's like I'm on the edge. I got this intuition for some of it, but let's just define our bind and hope I think the overlap will go away. Okay, so we'll make an extension parser. It's a function bind. It's going to be A and B, right? We don't know the types. We're going to take a parser. I guess I don't need the name parser. A parser of A, and a function of I don't know if there's a word for this function. Let's just call it function. I don't know if that's a reserved word. Doesn't look like it. Okay. This is A goes to parser of B. Is that it? No, it should just be A, I think. And it returns a parser of B. Okay. Single argument replace. Okay, yeah, that looks better. Let's return except R dollar whatever. Okay, I'm just trying to return. I don't know if I have a generic parser that will work. Well, we can do it kind of like this. Parser of B, input in this. I guess he returns something. Return I don't know. I was just going to say nil. Maybe this test just passes. Let's try it. I may have to do some renaming or something. Cannot convert. No, let's rename it just to make sure nothing's confused. monadBind. Okay. Cannot find monadBind in scope. Extension parser. Function monadBind. Let's just do a build. Now it gets all these other functions. Do I not need it in the extension? Maybe he's more like these other ones. He's not referencing the internal parser, so maybe that's the way it should be. I guess that test will pass. Generic test could not be inferred. Oh, it does have to produce, yeah, it has to produce a parser. So let's return, given a character, I guess we can do character.isDigit again. No, it's not a parser. It's a function. It takes $0. What would be an example? So this takes a character and turns it into a parser. I guess it's match. Okay, let's get this a little more formatted so it can make sense. match of this. Oops. Input goes down here. Okay, I need a function that takes a character and produces a parser with that character. Match string $0. Cannot convert value type character to closure result type parser of A. Cannot convert value of type character. Okay, let's see if it'll tell us types. Match produces a parser of character. So our first argument's a parser. That should be fine. Now we need a function that give me a character, because it's parser producing character. So give me a character and I'll give you a parser. Yeah. Thought that was too easy. Okay, let's pull them out. Let parser equal this. Okay. Let's give ourselves a function, a helper. It takes a character and it produces a parser of character. Okay, so if you give me a character, I can definitely do match where character equals $0. Okay. Function. Okay. He's still going to complain. Well, I'm just going to do clean. All right, and then rebuild. Sometimes Xcode's as confused as I am. Okay, this should pass. How helpful that is, I'm not sure. I guess it was helpful in getting the function types right. Test should pass, including the one. Yeah, okay. I don't know what I could return that would make that reveal that it's really a lousy test. Well, not lousy test. It just didn't drive anything because I just returned nil. So if we go back to this definition of bind, wherever I got off to. Bind, there we go. Okay, we're going to call the parser on the input, capture the output. If it's nil, then we return nil. If it's not, then we're going to apply the function to the value and return that. and I'm not sure where the array part goes in or out. So this is very experimental still. Okay, so if all right, let's test another bind. Bind succeeds when parser succeeds. Okay, so I will leave this broken out. Parser failed, yes. Okay, so if my input bind succeeds, well, bind produces a parser. Well, I do wonder if I can say character dot to upper. No. Wanted to make this a little more interesting, but all right. So what we're going to do is we're going to, I guess it's a parser succeeds kind of thing. The parser is the parser. The input should be a digit, 9x. The expected value is a parser of characters. I think the function, the parser is the bind, right? So it's a monadBind parser to, I think we can just say bind helper just to cut out a little noise. We bind parser to bind helper, and it'd be nice to get a 9 out of this, wouldn't it? Match character. We had a function for that somewhere. Where was that? Probably an Elm parser. Because we do convert characters to Elm integers. Let's borrow this for the test. I don't think that's too weird. Well, I could just say int of string. Yeah, let's just do that. Bind helper. It's not a match. Well, is it a combine? I don't know. Okay, I somehow want to do something. This parser, I got to call when I call parser, I call the bound parser. So I'm producing whatever the bind helper produces, which is the character that matched itself. I mean, yes, it will be the 9 in this case. That's kind of, it's not revealing. But let's get things working and then work on them some more. Okay, so this will fail. Okay, because we return nil. Yeah. Okay. And it would be very hard to debug what was going wrong, but we know. Okay, so what really has to happen? Okay, we're going to go back to this style of returning we got to return a parser of B already. Okay. This parser is Okay, so we're going to get a value back. I guess we'll say guard let value rest equal parser of input, else return nil. Okay, so if we try and parse A, why are you ambiguous? Without more context. Okay, parser takes input. If you're not going to tell me what input is, how can I tell you what this is? It's a parser from strings. Input is type string. Okay, let's try input dot contents. Okay, it's a my input, I guess. Not really a string. Maybe a problem. Parser. Oh, parse. Okay, so we're going to parse the input and get the value from that. If that fails to parse, we definitely return nil because the A parser failed. Now, okay, we're going to apply the function. I think it's the pair. No, we're going to parse. Oh my gosh. Okay. It's the thing we get back from the result. We want to apply the function to the value. I'll double check this thing. Okay, so we're going to apply the function to the value. Function. And then we're going to parse the input, the resulting input, the rest of the input. Is that non-escaping parameter function? I'm never sure on these. Okay. Now what? No, you can't make up words? Okay, it's just, maybe it's add escaping. Since they're saying it is escaping, I guess. We got to keep the function around long enough to use it. We can only apply to types, not declarations. Okay. That's similar to what we did up here, so I think that's probably okay. Okay, so we take our input. Are we applying it to the rest? Is that just what's going on here? Yes. Okay, I think that's what we're after. I'm not sure I've phrased that right. Okay, let's run it. Pass or fail. We're going to take a break when this finishes. Okay, let's take a break. All right, hello again. Okay, so I think what this is saying is the test is wrong because the parser is supposed to apply. It's supposed to parse the rest of the thing. So we apply p to the input, and then we apply the function to the value, and then apply that to the rest of the input that came back from here. I'm confused about if I need these bracket kind of things. I don't know if I need that, if that's a consequence of him defining his parsers to return arrays where we just return optionals. But somehow, right, a sequence has to return a list of stuff. I don't know. Result XY. Let's see what that result thing does. It's just sort of the one that shoved things into the front. Result XY is going to return the pair XY. I just don't know. We'll see. At any rate, I think I got to make my tests a little different. So excuse me. So what I think we're looking for is a parser. I think we're looking for a parser that matches. I mean, if character equals $0, we call character on the rest of the thing. So I think I'm looking for inputs that match. They're requiring the second character to match the first, I think. But I definitely will consume both characters. And I think when we think in terms of a sequence parser, which this isn't quite that, but it's kind of a piece of it, we want to consume the first part and then the second part. So it makes sense that it does that. So, like I said, I'm kind of working my way towards understanding this thing. But, okay, so we parse our input, apply our function to the previous one, and then parse the rest. Okay, let's see what we get. I don't think the expected string is right, because I think it's probably going to be 99 or 99 pair, or I don't know what. That's where I'm getting lost. Okay, why is it a 9 and not the 99? Because it's returning. Yeah, it's only returning the result of the second parser. It calls the first parser and returns the result of the second one. So if we wanted to parse match something and skip it, this bind is kind of handy. So that sort of sounds like what we're doing in comment land there. So I think that's maybe useful. I don't know. It would seem to me like we need both the values, and maybe that's just the function we choose has to do that. I mean, I could imagine something that did parser of string and returned back no, I'm not getting there. So, all right. So, let's take one more let's say this is when inner parser fails. First parser fails. Succeeds. Let's do another fails case. Bind fails. when second parser fails. I think the implementation order and the story order are different here. Okay, bind succeeds. Bind fails when first parser fails. Bind fails when second parser fails. Bind succeeds when both parsers succeed. Okay, and let's see. So I think this one is a parser rejects. So I believe if your input is 89x, the characters are not equal, and it should reject it. Okay. But bind helper. Okay. But this case, I guess, is unchanged. The characters match. So bind helper, let's rename that to character matches. Okay. Maybe a little better. I'm hoping everything passes. Yes. Okay. Huh. Now, wowzers. Yeah. Okay. So I think bind is kind of working here. I mean, it's doing what it's supposed to, I believe. Modulo, or except I'm not sure about the returns of arrays versus not arrays. I mean, part of what I understand with monads is you're trying to work in sort of it's almost like, I mean, it's kind of like category theory tough stuff too. You want to have an identity element and an associative operator, and if you have those two things, I think that's sort of equivalent. I don't know. There's some equivalency of that to bind plus something else, I think. But if you have those guarantees, then you can kind of sequentially choose which things to mush together first. It's associative, so we can group it how we want to, and then apply rules about that. You know, that we know that stuff with associative things, there's properties we can do. You know, you can do this one or that one first, and you get a little rectangle thing in category theory that says doesn't matter which way you go, you get in the same place. I think we're kind of in that mode. I mean, it's very hard for me to get this because everything's so indirect, and I don't know. That's like somehow I'm going to get things so that the monad binding and the associativity is going to make it so having an array of stuff, I don't care which things work together first, but you know, like in our sequences, as long as they all glom together in the end, you don't care what order they merge together, and sort of like bottom up and top down parsing, right? They both end up at the same place in many cases, but you don't have to care whether it was, you know, top down or bottom up. If you get the same parse tree out, let's say it that way. Now, this confusing thing, 209 is where it really gets weird, but I think I'm kind of getting something out of this. I don't know. It's like a little 4-line function to really study. You give us a parser, we use it. Given the thing it produced, we're gonna make a new parser, taking that value into account, and then parse the rest of the stuff. All right. And so anytime you can think of something that parses the rest of the stuff, I guess this monad will be helpful to you. All right. In particular, we're going to try and do a sequence, and Um, I don't know. I'm still not quite seeing how his sequences, and maybe this concat is going to be the thing that bites us. I don't see how his sequences return. I mean, result X, Y. I guess it's just an ordered pair of stuff. We don't have a result function yet, so let's put that in. I don't know. That name doesn't do much for me. I keep thinking inject, but inject is overloaded. We'll just say result for now. So the result function is you give me a value, I'll give you a parser that always returns that value first. So it's sort of like a constant, but it's thrown in. It's a parser. Well, it's like a hard-coded value or something. We're injecting a hard-coded value into the stream. Nothing. We're not even looking at the stream, right? Input goes to something with input, so the input stream is untouched, and it's like we're just saying, I just sure wish my input stream had this value in front of it. Let's make something that throws the value in front. Okay, and notice he produces an array there, and that may be the breaking point for us. I think our result is just going to return the value itself. I mean, it's going to return the pair. Okay, and let's see. It's so input goes to, it's returning a parser. Let's try this result thing. And this is very different. I don't know. We're doing a refactoring in effect. I mean, I'm trying to do a refactoring to replace all my sequences that get all balled up with this new monad sequence thing that's supposed to not get all balled up. And it's almost like a replace algorithm refactoring, which is kind of like, rewrite your whole algorithm and then substitute it in one big go. It's not a incremental refactoring. But I think if we can get ourselves up to a sequence operator and use that, we can sort of use it one at a time, get rid of some onlys and some unwraps if that's what this thing results in. But I don't know if that's what it's doing. So we're in spike territory here, basically. I'm spiking out this new approach of a parser combinator that's built around this monad thing. So it's happy to work with it. So, and I think the way the monad works is monad just says, I've got a type. You promise to give me an empty. You promise to give, or an identity element. You promise to give me an associative operator. And then I can manage lists of these things coming together, groups of these things. But anyway, okay, so function test result puts, I don't know, injects, what's the word we want? Inserts a hard-coded value. Okay, and so if we say parser equals result, that word is terrible. What word can we use? Okay, we'll get it. We'll use this for now. Result of hello world. Okay, and then the parser succeeds. Yeah, we should see that back, I guess. Okay, so it puts a string value in there. Input is something else. It gets back hello world, and it still has something else. Let's call it rest of input. Original input. Okay. So this is, I don't know, it's slipping something in, it's injecting, it's inserting, it's what do bad actors do to your communication stream when they insert a fake message? That's kind of what we're doing. Okay. Result of hello world. Okay. And I mean it's just a function. All right. Let's say result. We got to get result of some type. We get a value of that type. We produce a parser of that type. Okay. And I guess it's just going to be, well, let's see. I don't have a supply of useless little parsers. Anything that returns a string? No. Do I even have anything with strings beyond my input? Match? No. Takes a string, doesn't return a string. Well, I can make a parse that always fails. it takes an input and it returns a failure. Okay, does that satisfy it? Okay. Cannot find result in scope. Let's build. This should fail. Oh. Cannot convert character to parser character to expected type string. Oh, wait. Let's use parser. Okay. This should fail. It should come back with a nil and just fail. Okay. And I mean, all we're going to do instead is we're going to return input in, and we're just going to return a and input, I think. Oh, $0 no value. Okay, while we're doing this result, what do they call it here? Result maps this to its input. Okay. Now we need our sequence. So P sequence with Q is P binds to the function X that takes Q and basically takes the X and the Y and returns the result. Bind cannot be defined in terms of seek. Okay. So using the bind combinator, we define other things. Yeah. Apply the parser and its return value. Combine all results to a single value by applying F. Now, what confuses me is it looks to me like PCQ, if I had to say his type, it's parser A, well, parser P, parser Q. And what's it return? It returns a pair. It returns a, let's say both are parsers of A, right? It returns a pair AA with the rest of the input. Oof. Okay. All right, let's define this thing. Sequence. Okay. And maybe this getting the test written will be enough. Okay, we'll call it seek just to be different than our existing sequence. How about fails if first parser fails? Okay, and the parser is sequence of match A with match B. Okay. And I feel like the inputs, well, the inputs XA. And the expected, this is where I'm getting, I think the expected is, well, no, this is a parser fails. So let's use one of those. Parser rejects. Excuse me 1 second. Sorry about that. Okay. So it's going to be a parser rejects. Okay. And he's going to reject sequence, our parser, with the input well, let's say XAB should fail because it expects to have an A, then a B. It does not. Okay. We can frame this thing in. This is a function. Now, should this be a combine? I mean, a extension? Not for now. Sequence of A. It's going to have a first parser and a second parser. And it's going to produce a parser of, I don't know, A, B. I think that's what it's asking us to do, which seems like it won't work. Well, AA. Okay. And we can do parser, just a failing parser all the time. I guess that makes our test pass. Cannot find type parser in scope. Yes. Well, I could call match. Yeah, I don't know. Let's return this and see if see the test pass. Maybe not for the right reason. I don't want those arguments. Okay. We got, in effect, I think we're setting boundaries. It's AB, so A, XB. This should fail. No problem, because all it does is fail. We'll write our next test and then call it a wrap. It'll fail and we'll fix it tomorrow. All right, so function test sequence passes if both parsers pass. Now I've been using succeed. both parsers succeed. Okay, that's more like one of these. Okay, and so our parser, let's keep with this thing. I believe my expected result is A, B. And the, so our input, oh boy, only structs can do that. Yuck. Input is A, B, X, and the rest is X. Okay. Cannot convert value of string to expected argument type character. Let's go to parser succeeds. He wants an expected type that is equatable. And we've assumed it's the same on the way out. Yeah, we have a parser returning list AA, so it's not character, array of characters. I don't know. This is where it's gonna What is parser? Does it tell us? No, I want quick help. Parser returns, wow, an array of characters. That is not what I expected. What does result return? You give me a value, it returns a parser of that value. I guess we're not calling results, so why should we notice? Parser of A, parser A. Parser yields, let's go back to parser. What is its definition? Parser for A yields A on the input and A on the output. I don't know. This is unexpected to me. Cannot convert value of type string. I mean, yeah, I could expect character, but how does it know it's a string? Oh, it's argument array of character. Yeah, that's probably back to our match. Right? Yeah, match prefix produces parser of array of characters. All right. Well, I think we'll pick up here tomorrow. Let me just try adding brackets in just to see if that's the whole issue. Yeah, I think we're still going to have the equatable issue. Right. Okay. We'll pick up there tomorrow, Thursday, 1 to 3 p.m. Eastern Time. Thanks for joining me today. I think we're getting into the core with the results and the parsers and all that. We're kind of getting into this core piece that I hope makes all this stuff hang together a lot better. And once that does, I think we'll get rid of all those unwraps and onlys and certainly my intuition is I shouldn't need all that. So I'll see you tomorrow, I hope, or another time in the future. Take care. Bye-bye.